Hello, thank you for coming. Today we'll look at factoring polynomials. So from earlier videos, you know that a polynomial is simply a group of monomials, two or more, in which there is addition, subtraction. Uh, so you know that a monomial can be any term can be a constant, uh, a variable, or a variable with a coefficient. So we can have, say, 5 is a monomial, x is a monomial, x squared is a monomial, xy cubed monomial. And then when we combine two or more, we have a polynomial. And a polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. So, now we're going to look at factoring. So, in order to factor a monomial, or a polynomial, we do the same that we would do if we were factoring an integer. So if we're factoring, say, if we want to find so the concept of factoring a polynomial is the same as finding the greatest common factor of some numbers a and b. So the greatest common factor of a and b, n, is the largest integer such that the largest integer that evenly divides both a and b. So a over n and b over n have no remainders. So if we have a and b as 4 and 8, for example, the greatest common factor of 4 and 8 will be 4. The reason why is that 4 is the largest number that divides 8 and 4 evenly, 2 and 1. If we had, say, greatest common factor of 12 and 16, 12 and 16, then that would also be 4, because 4 is again the largest number that divides both of them. So now let's go on to factoring polynomials. The first one we're going to look at is 5am minus 5an. And, as I said, all you have to do is look for the largest common factor, the GCF, of these two terms, 5am and 5an. The greatest common factor is 5a. And so what we do is we write this to factor the polynomial. We write this expression as a product of factors. So we can rewrite 5am minus 5an as 5a times m minus n. And when we multiply this out, 5a times m minus 5a times n, we have the original expression. And that shows that we did our factorization properly. if we have 2c to the fourth minus 4c cubed plus 6c squared, well, we see that the largest power of the smallest power of a coefficient is c squared. All terms have a coefficient, and the smallest is c squared. The other thing we see is that the coefficients are all multiples of 2. So if we were to take out 2c squared, use that as one of the factors, what would be remaining would be the c squared minus 2c plus 3. As you see, if we multiply this out, 2c to the fourth minus 4c cubed plus 6c squared. Okay, so it's not really that hard. Now, we're going to look at a little bit of a harder example. Well, first, let's try this. We'll try to factor this. So, in both terms, we see that there's an a, so we can factor that. We also see that both the coefficients of the a, b, or a terms, 3, multiples of 3. So, if we can take out 3a, and what we'll have is 2b plus 1. And you'll see 6ab plus 3a. What we have when we multiply it out. Now, this one is a slightly harder example. 5x cubed plus 10x squared minus 20x. But it's very similar to the one that we did with the c's. So all the terms have an x in them. This is x to the first, x to the second, x to the third. So if we take out an x, and also noticing that all of these terms have 5 as the greatest common factor, their coefficients, 20, 10, and 5. We can take out 5x, and what remains is x squared plus 2x minus 4. Again, multiply that out, 5x cubed plus 10x squared minus 20x. Now, this one is r times t plus 1 plus s times t plus 1. Well, we can see that both terms, r times t plus 1 and s times t plus 1, contain t plus 1. So we can factor out t plus 1 as the largest term, our largest common term. Now, okay, so one method of factoring is factoring by grouping, and we use that sometimes when it's not so clear that there is a common term, such as in this one. So in order to factor this by grouping, one thing we can do is we can group the terms that have common numbers or variables as a factor. So by that, we see that x is common to both of these, and 2 is common to both of these. So we factor these individually, and what we get is x times x plus 1 plus 2 times x plus 1. And that becomes much easier because that is, well, it's the same as what we just did. X plus 1 times x plus 2. And we find that if we FOIL, we will get what we started with. So x squared plus, so x squared plus x plus 2x plus 2. So so now what we'll do is we'll start we'll begin to look at factoring trinomials, quadratic trinomial. So before, however, let's look at a couple of special formulas. Well, the first is that if we want to factor a polynomial of the form a squared plus 2ab plus b squared, we can factor it in this way: a plus b times a plus b. And you can see that works, because if we were to multiply the first terms, the outer terms, ab, the inner terms, ba, and the last term is b squared, we would get a squared plus 2ab plus b squared. And if we want to do a squared minus, if we want to factor a polynomial in the form a squared minus 2ab plus b squared, it would be a minus b times a minus b, or a minus b squared. So this is also a plus b squared, a minus b squared, which same thing. First a squared, outer, inner, and the last ones 2ab plus b squared. And from this you can see a couple of things. The first is that when the last term in the polynomial is positive, we know that, well, we'll come to that later, actually. Be better to talk about that later. The next formula is that a squared minus b squared is equal to a plus b times a minus b. And the way that works is that the inner and outer terms cancel. What we have is a squared minus ab plus ab minus b squared. And all that remains is a squared minus b squared. So we can spot these polynomials by knowing whether or not the polynomial is a difference of two squares. So, for example, we have 4a squared minus 25. We know 4 is a perfect square, it's 2 squared, and 5 is a perfect square, 5 squared. And it is a difference. So we know automatically that we can factor this one as 2a plus 5 times 2a minus 5. So 4a squared, and the middle terms don't matter, at minus 25. So if we have two terms in our polynomial where both terms are perfect squares, then we can always factor it in that way. That rule is very useful. So now we're going to look at more general types of factoring, or I say more specific forms of factoring, but they're more general than these cases, these special cases. And what we're going to look at is specifically is factoring quadratic trinomials. So quadratic just means that the highest power of the polynomial is x squared. And of course trinomial means that is a polynomial with 3 terms. These are 2 quadratic trinomials. Now, to factor these, we know we're going to divide. We're going to form 2. We're going to multiply 2 expressions together that have that 2 expressions together that are binomials. So now first, to make this easier, we do a little bit of detective work. Let's see. So I guess before we do the detective work, it would be prudent to look at how it works. So this one factors to x plus 2 times x plus 4. And this one factors to x minus 2 times x minus 4. Okay. Now the detective work comes figuring out how to find this form of the polynomial or trinomial. So first thing we notice is that the first term, x squared, comes from multiplying together x and x. So we know that this is going to be the form of our factor form. This is going to be the factor form. And we just need to find the signs and values of a and b. So the first thing, because we know that when we take a positive, multiply by a positive, we get a positive. We take a negative and multiply by a negative, we get a positive. Sorry. Take a positive and multiply by a negative, we get a negative. So we know that the last term can only be a product of 2 negatives or 2 positives. So we know that they have the same sign, either both negative or both positive. The other thing we know is that this middle term is positive, and we know the middle term comes from adding together these constants times x. Well, these constants times the other terms here. So what I mean by that is they come from adding together 2x and 4x, because this is 2 times x, 4 times x. So we know, because this term is positive, that at least because we know that both of them have to be the same sign, and this term these terms add to get a positive number, we know that both the terms have to be positive. A and b have to be positive. We already knew they had to be the same sign, but because 6x is positive, then they have to be positive, because they have to add to get to a positive number. The other thing we know is that a times b is equal to 8, and a plus b equals 6. So the only number that will give us this will be a equals 2 or 4, of course, and b equals 2 or 4, of course, because 4 or 2, because of the commutativity of this operation, multiplication. Oops. We know that x plus 4 times x plus 2 equals to x plus 2 times x plus 4. So that is our detective work. Now let's sort of clear this out. we know the other one, x squared minus 6x plus 8. So doing the same detective work, we know because this is positive, they both have to be positive. However, because this is negative 6x, then they both have to be they both have to be the same sign from this term. But because this is negative 6x, they have to be both negative. So what we have is x minus something times x minus something. And these terms, a times b, that's equal 8, and a plus b is equal to negative 6. Well, again, the only numbers that do that would be negative 4 and negative 2. And that is all there is to it. One only needs to master the detective work, let's say. So if we have the trinomial x squared plus 14x plus 40, well, what we can do, so again, it's going to be x plus or minus something, x plus or minus something. Immediately we know that they both have to be positive, because again, positive term here, so they both have to be positive or negative. Because this is positive, they both have to be positive. So now we just need to find two terms that multiply together that equal 40 and add together equal 14. Well, let's think. We look for factors of 40. We've got 2 and 20, 4 and 10, 5 and 8, let's stop there. 4 and 10 we know. So 4 and 10 work because they add to get 14 and multiply to get 40. Okay, so we'll continue this in a later video. Thank you for thank you for watching the video. If you have questions on a topic, simply ask and we'll make a video for it. Thank you.